Alrighty, welcome to video number 3 of section 2.7. We're still playing with the power rule shortcut. We're playing with the shortcuts for the derivative of sine x, cosine x, e to the x natural log of x. So we have 5 different rules that we're learning for 5 different types of functions. But sometimes we get this. This is a mixture of those types of functions. And now we don't necessarily have equations, although we do, but we also have tables, and we also have graphs. So there's like everything in these types of problems. So I'm kind of excited. All right, example number 2. The graphs of the functions f of x and g of x are given above. So we can see the graph of f of x, we can see the graph of g of x, along with selected values of h of x, as well as its derivative. Not only that, PC people, we also have the second derivative. So not only do they give us the first derivative, but the second derivative of h. Use the information above to find the following values. All right, here we go. This is the rookie mistake that some students make. Whenever they're asking you to find the derivative value, always find the derivative first and then plug in the value. So when I look at, and I'm going to do my derivatives in blue. When I look at this equation, in order to find k prime, I need to find the derivative of this whole thing, and then I'm going to substitute the 1. So what's the derivative of sine x? According to our shortcut rule list, it's cosine x minus the derivative of 3 times g of x, well, that would be a constant, times g prime of x, plus the derivative of x squared, well, that's 2x. So think about where those 3 pieces came from. The derivative of each of these sections, and I'm allowed to do that because of the sum and difference rule, which says if I'm subtracting or if I'm adding, I can take the derivative of each piece and then put them back together using those operations. So here is my derivative, but we are looking for the derivative. Here's my derivative equation or my derivative function, but we're looking for the derivative value at x equals 1. And so x equals 1 means we're plugging in a 1 wherever I see an x. Well, the first part and the last part are pretty easy because cosine of 1, it's not one of the special angles on our unit circle, but this is the answer, cosine 1. And over here, I can multiply 2 times 1 and get 2. So I could say cosine of 1 plus 2. But here, I got to look at the graph of g and find the derivative at x equals 1, and then multiply it by 3 and subtract that whole answer from the other two. So g prime of negative 1. So I'm going to come over here to my graph, and I'm looking for g prime of 1. Well, here's 1, but I'm looking not at the y value, I'm looking at the derivative. So I need the derivative of this line segment. Well, the derivative, it looks like it's going down. It's a slope, so it looks like it's going down 1 over 2, right? Or in this case, down 2 over 4, which reduces to negative 1/2. So the derivative at that blue point, not the y value, but the derivative is negative. The slope is negative 1/2. So I come back over here, and I say this is going to be minus 3 times negative 1/2. And then I'm able to just say, oh, the final answer, I guess, is cosine of 1. Remember that we're multiplying these, so when you multiply a negative or a minus 3 times negative 1/2, you're going to get plus 3/2, which is 1.5, plus 3 plus 2, that's 3.5. And so you could say plus 3.5. You could write it that way. You could also write it this way, because that does give you 3.5. But because I can't find cosine of 1 without using my calculator, and my calculator is going to give me a decimal approximation, which I'm going to have to estimate, I'm just going to leave the answer like this and say that is our derivative value. That's the exact derivative value. Without using a calculator to get a decimal, that's going to round my answer. This is the final answer. Let's see. Where do we go now? Where do we go now? So many places. Let's do letter C here. We'll do a couple, and then I'll ask you to do some and see, and we can check them in class. We need to find the derivative. So don't plug in a 4 yet. So n prime of x equals the derivative of this. Well, that's just h prime of x. Minus the derivative of this. That's just g prime of x. Plus the derivative of this, well, that's 0 because 1 is a constant. Constants don't change, so there's no rate of change, and that would be 0. Okay, now we're getting ready to plug in or substitute a 4. That'd be h prime of 4 minus g prime of 4. H prime when x equals 4. Okay, so that's in the table. When x equals 4, my h prime is 1. Do you see how we did that? When my input is 4, my derivative value is 1. So I got that one, 1, minus g prime of 4, the derivative at 4. So I go to my table, I'll go to my graph. So now I'm not looking for this. I'm looking for this. When x equals 4, that would be right here. I'm looking for the slope at that line, at that point. But that would be the slope of this line segment, and this line segment looks like it's going up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. So my slope is just 1, or 1 over 1. So I come back over here, and I write this is 1. Oh, well then that means my final answer is just going to be 0. Pretty straightforward. We're following either the graph to find slopes, the table to find specific values, or a function in order to use our shortcut rules in order to get the answer. Letter E looks really interesting, I'm going to say. Letter E, we're going to find the derivative first. Q prime of x. Well, the derivative of e to the third, remember, e is a number. So I have a number as a base. I can't use the power rule, right? The power rule, this has to be a variable. This has to be something that doesn't change, or something that does change. E doesn't change. It's a constant. So if I have a constant to a constant, that's a big constant. The derivative of any constant is 0. Minus. Here I have a power function because I have a base that's a variable and I have an exponent that's a constant. So then I can do the power rule and say e x to the power of e minus 1. What is e minus 1? I don't know, but that's the way I do it, right? Plus, here I have an exponential setup, so then this is just e to the x. That is my derivative function. Oh, but we want to find the derivative at 4. So wherever I see an x, I'm about to substitute a 4. And therefore, my final answer is negative e times 4 to the power of e minus 1 plus e to the 4. That is my derivative value. It looks wonky, it looks weird, but that's what it is. We're able to use our new function derivative shortcut rules to figure out these maybe unorthodox setups. I want to do letter G, and then I'm going to ask you to do some from the set so that you can practice. Got to find the derivative first. S prime. Here's a good example of why you should always plug in later after you find the derivative. The derivative of f of x is f prime of x, right? But here I got to be careful. The derivative of h of 1, well, h of 1 is a constant, right? Because if I go back to my table, we're saying, I don't think my pen wants to erase. We're saying when x equals 1, my output is 7. So h of 1 is actually 7. So when I take the derivative, well, that's just going to be 0. So this is plus 0 minus the derivative of the natural log of x, that would be 1 over x. So s prime of 8 is f prime of 8 minus, this goes away, 1 over 8. Well, what's f prime of 8? Let's go to the graph and see if we can figure it out. Here's x equals 8. So we're talking about this point right here on the F graph. What is the slope of this line segment at that blue point? The slope is -1 because I go down 1, go over 1, down 1 over 1, down. You can go down 3 over 3 and it's still going to be -1. So the derivative value of this function f at x equals 8 is -1. So I have -1 minus 1/8. Well, that's -1 and 1/8, which is -9/8. And there's my answer. So if you would practice a little bit, excuse me, I'm going to ask you to, on the front page, if you would, do letter D. Maybe I'll do it in the highlighter. Do letter D and C. And then on the back page, see if you can do letter F, letter I, and letter D on the back page, just to get some practice. We'll check it in class.